Hi, Geoff Montgomery here from Accurate Rifles and Restorations. If you're new here, thanks for watching and feel free to peruse around and check out my channel. I am a very highly experienced gunsmith specializing in highly accurate rifles, lots of experience building centerfire rifles and highly accurate hunting rigs. I use a lot of different techniques to true up or blueprint, accurize centerfire rifles primarily. Well, I've decided to throw my hat in the ring and enter the realm of the rimfire game. I hope to earn your trust and perhaps your business, kind of showcasing what I'm going to do here. But we're going to basically use the same principles and techniques involved in truing up a centerfire rifle and creating the most consistent and highly accurate rifle possible, where we'll take a factory mass-produced, manufactured action, basically strip away all the components and leave us with a bare bones action, being a receiver and a bolt. And then we'll go through and true up, basically remachine all the surfaces straight and true in order to provide the best possible starting point for the best possible rifle. So if you're curious, you can peruse the past videos. I have one in particular called Blueprinting Done Right, where I kind of go over that process in great detail, so you can kind of see that. Well, like I said, today and moving forward, we're going to be offering this service to the 22 rimfire crowd, primarily, at least starting with the CZ457 platform. So here's a CZ457 you would get. This is bone stock right out of the box, synthetic stock and factory barrel, very thin, and your bare bones action here. So we're going to basically transform this into something that's going to be able to compete with the highest level, especially in the NRL series. Namely and primarily replacing the barrel and going through and truing up the receiver. There's a lot of aftermarket parts that are going to be installed. The extraction system here will be improved upon with the Desert Eagle Precision Talon. That's the best on the market that I could find. Like I said, the receiver will be trued up, and we're going to be actually cutting threads in this thing to install a brand new barrel. So we're going with a real big Krieger barrel. So we've got a couple of these barrels already in the shop. We've got a couple Mauler Works and various other 22 rimfire specific barrels in a 16 twist configuration. But this is a big honking Krieger barrel that's going to be installed on this thing. It's a 1.250, so 1 inch and 1/4 diameter. And we're probably going to finish this at 24 inches. That seems to be the magic number for length on most of the 22 rimfire precision rifle builds. So on the table here, we've got a whole bunch of tooling that kind of can cross over into the 22 realm. A lot of the techniques are the very same. We're basically going to use bushings to align the receiver in a very highly precision, heavy lathe, using the blueprinting jig you may have seen on the other videos. We're going to use this in conjunction with the alignment bar and precision bushings to get the thing running straight and true, both axially and radially. Then we're going to go in there, cut the threads, face off the action, get everything prepared for the new barrel. So we're going to break down all these processes in the video, kind of showcasing what you're going to get for my level of service and what I can provide you in kind of a niche market here. I'm excited to throw my hat in the ring here and kind of get going. So if this is something that interests you, don't hesitate to get in touch. We can discuss things. I can kind of prove my worth, as it were, with plenty of other videos here that you can watch and kind of show you that I know what I'm talking about and I got a lot of experience in this game. Maybe not the rimfire yet, but again, like I said, it crosses over most of the principles and techniques and ideology are the very exact same thing. You know, we're trying to squeeze the most amount of consistency in precision and accuracy as we can out of a device that shoots projectiles through the air into a target. So this will probably end up being a series. Like I said, we're going to go through the detailed process of my journey converting this stock CZ Česká zbrojovka 457 typical rimfire into a super accurate precision rifle worthy of competition level results. We're going to be using the Vision chassis. Now this is not assembled yet, so I'm going to take the fore end off. But very high quality, one of the best in the market today, Vision chassis. This is made in Norway and has all the adjustments one would ever need or hope to have on a precision rifle chassis, including a side folding buttstock. So we're going to give this the works, just like any centerfire rifle. This will be bedded in place and installed later on. We're going to be using, like I said, a Krieger 1.250 inch diameter barrel, very heavy. This thing seems to weigh probably around 8 pounds already as it is. And we're going to try a whole sampling of Eley ammunition. For the ammunition, I have a special custom Eley style reamer here made by Pacific Tool & Gauge. This is for the Eley style ammunition. I will head space it appropriately, but the dimensions of the chamber will match the Eley footprint ammunition basically perfectly. And like I said, we're going to be using precision bushings in order to align the receiver. They're not tapered bushings, they're actually precision fit, incrementally sized in half thousandths of an inch to find the exact diameter of the internal bolt bore raceway of this particular receiver and receivers moving forward in the future. So yes, I think the next step in this process obviously is going to be breaking down and kind of going over the original configuration of the Česká zbrojovka 457 rifle, its limitations as is, and the improvements we'll be doing in detail on this particular rifle here. Again, my name is Geoff Montgomery, and I represent Accurate Rifles and Restorations here in Casper, Wyoming. I hope to showcase my abilities and hope to earn your business moving forward. So join me in this journey, and we'll turn this into a precision rifle for competition use. All right, so here on the bench, we have our victim, our Česká zbrojovka 457, or CZ 457 as it's known here in the United States. Bare bones configuration. So first thing to do in this process is basically strip away all the things that we're not going to be using. Basically got 2 action screws that hold the action into the stock, held in by 2 T20 Torx kind of taper head screws. Now the Vision chassis comes with a little bit higher quality button head or cap head style screws to retain the action into the new chassis system, so we won't be saving these, or we won't be reusing these at least for this build. So as you can see, a skeletonized stock, bare bones, very lightweight, kind of cheap, skeletonized, hollowed out stock. Not going to be using this, so that's all we're going to say about that. But this is what you would get basically with a factory fresh configuration. I know a lot of these rifles come with wood stocks, a lot higher quality and whatnot, but since we're not using it, we don't care. So let's set those things aside. Then the receiver on the side has a typical side bolt release here. So that will enable us to release the bolt, get that out of the way. There's not a whole lot to talk about on the bolt. It's a typical rimfire bolt action style bolt. There are no locking lugs really to speak of. It's a little bit different technique. There's not a lot of truing we could do to this particular part of the build. So basically all this does is holds the cartridge and detonates it and then extracts it, and then there's a secondary ejector in the receiver here that will kick the case out. So the bolt itself isn't going to get a lot of love in this job because there's really not a lot to do with it. However, we will be replacing the extractors for the premium Desert Eagle Precision Talon extractors. So those have been ordered. They're in the mail to us. We will install those later on, and we'll get into the benefit of using those style extractors over the factory originals made by CZ. Moving on, we have a magazine well. Basically, this is where the magazine enters through the bottom of the stock and is held in place by means of this plastic catch. So to release it, you pull this portion back rearward and it will release the magazine. This is all plastic construction. We are also going to be replacing all this with DIP products. They make a very high quality aluminum magazine well block back here, and we're going to buy an extended release as well. So, big drawback to a CZ 457 is the way in which the barrel is held in to the receiver. Not to get into too much detail, but a typical centerfire rifle, at least one of higher quality, has a barrel that is threaded in. Basically, the receiver will have internal threads and the barrel will have external threads, and those will obviously screw into each other with a very, very good, tight mechanical fit. Those are typically torqued into place under quite a bit of foot poundage, which creates a very strong bond and a good fit between the torque shoulder of the barrel and the face of the receiver itself. So that locks the two together. In a centerfire rifle, there's a lot of recoil, there's a lot of pressure, there's a lot of things involved that you just do not want these two unions to come apart in the field. A rimfire obviously is dealing with a whole lot less recoil and a lot less pressure, but for consistency's sake and highest accuracy potential, we want to do away with what they are using here. So here, at the bottom of the receiver, you're going to see a pair of grub screws. So that is what is actually affixing and holding the barrel into the receiver. So we're going to take a appropriately sized Allen wrench, and these are snug. They're not super tight. They're not Loctited into place, which I found kind of surprising. So basically, you just unscrew these two grub screws, which will release the two components. So you can see they're held in at somewhat of an angle, so that is putting sort of rearward pressure on the barrel, kind of forcing it into place. So, yep, two of these are what's holding this in. Here is your factory barrel. The grub screws interface right here, kind of pushing rearward on these two angled surfaces. And you can see how deeply those are cut into the barrel. Now those cuts are coming extremely close to the internal diameter of the bore. And in layman's terms, when you're cutting away a lot of this steel, that basically stress relieves a lot of the portion here. So you're basically opening up the internal diameter of the bore by removing that much steel. That is actually exactly where the throat would be. So you can see a 22 rimfire sits in the chamber just like that, bottoming out on its rim. So that cartridge will stop on the rim of the case, right back here. So if you look at it, outside of that, this is where it's going to stop, and look where those cuts are. Right there, where the throat of this chamber is. And the throat in the chamber is basically the very beginning of the rifling. So it's a little bit, they call it free bore, so the bullet itself, the projectile, when it detonates, it has a little bit of free space until it engraves into that rifling and goes down and spins through the barrel on its way out of the muzzle. That's one of the most critical portions of the entire barrel, is the throat area. So you've got your chamber, the throat, the transition, the free bore into the rifling. And if that's oversized and not engaging, or a long free bore, the bullet has a lot of jump until it actually engraves into that rifling, continuing its path out the muzzle. Well, we're going to do away with those things. Those things are a killer for accuracy. And that's why a lot of pre-fit barrels, especially for this particular system, that is their weak point, literally. Those giant cuts in there. Okay, so just for comparison's sake, this is the original factory barrel, and this is what we're going to be replacing it with. A little bit of a difference there, I'd say, in girth and length, and quality, obviously. This particular one is made by Krieger, which is a very high quality barrel manufacturer. They've been around for a long, long time, been making great, great barrels. I use a lot of their barrels for center fire builds. They all shoot amazingly well. They're easy to work with, easy to machine, just great all-around barrels. So I thought that would be a really good contender to start out this, this journey doing with a known, really well-made barrel. This barrel is a 16 twist with a 217 bore, a 222 groove diameter. That's typical of any rimfire. So this is specifically a rimfire barrel. Just thought I'd show that. That's going to be the barrel that we're going to be replacing with, or from this one here. Now to get into the receiver work that we're going to be doing, kind of the feature of this video. So we're going to take this receiver here and basically cut threads inside here. We need to cut threads in order to have a threaded barrel that will be properly torqued onto this receiver face here. So this process is very similar to the way I remachine any centerfire bolt action. Any bolt action rifle on the market, being a bolt action, has what's called a bolt bore raceway. So that's basically, that is inside here. It is the inside of the receiver. The receiver is essentially a piece of steel with a hole through it that enables a bolt, which is the ammunition feeding, firing, extraction, and ejection mechanism of the rifle. So the bolt has a lot of jobs. The receiver, all this does is hold the barrel on and holds the bolt. But being that it has a very small job to do, it has a very important role in the whole system, which is holding everything square, perfectly aligned, and consistent. So we want consistency, which means we're going to take this mass-produced tube, essentially, and true it up to a known center line, which in this case, in a bolt action's case, is going to be the bolt bore raceway. So the center line of our receiver here is going to be our datum line for basing all of our cuts and truing up this whole system off of this known center line, which corresponds to the center line of the barrel, corresponds to the cartridge sitting in there, firing, having the best start at life that it can possibly have. Well, we need a way to properly machine this square and true, axially and radially, meaning both this way and this way. Well, just like in a Remington 700 style, we use a series of bushings. So these are custom-made bushings that I've ordered incrementally sized for the bolt bore raceway. Measuring the inside of this, you get anywhere from 705 to 710. That's kind of the general area of internal diameter, so 0.705 thousandths of an inch. And so we get bushings made, and this one's made by Grattan Rifles. This is a 7085. So we've got 7085, 709, 7095, and 710, a pair of the 785s. So basically, just like a centerfire bolt action, we're going to take these bushings and see which one fits the best. We do not want something like this where it's very loose. So this 7085 will pass all the way through and gets a little bit resistance at the very end here. Gets a little bit tight, which is telling me the internal receiver here is actually tapered just a little bit, getting a little bit tight and snug at the very end of it, right around this area. So it's loose and then tightens up here towards the end, but I can still pull this out without too much effort. We'll step up to the 709. We'll see how that one fits. Now again, these are actually sized bushings. They're not tapered. I don't feel tapered bushings are the best way to go because they have a tendency to, the taper will sit at the highest point of that and generally not sit perfectly square. It's going to sit on one point, that being the biggest part of the taper. So that's why it's best to use actual sized bushings for this kind of work, at least in my opinion and my experience. So the 709, you can see it's not dropping free like the other one was. And this one is actually getting quite tight towards the end here. So that one is bearing pretty well in the end of the front of the receiver here. So the 709 may be the contender for this particular action. See if we can get it to sit just a little bit further forward. And that one is basically stopping right there. So it's not fully protruding through here. So in this case, we may actually step back down to the 708 to get it to bear evenly and appropriately, because we don't want this tight of a fit. If I can't push it through by hand, we're going to be forcing things, and we don't want to force anything in this particular work. So let's push this back out. So we're at a 709 there. Like I said, the 7085 may be the one we're going to be actually ending up using, because it does get quite tight here at the end, but it can be pushed all the way through. But right there, it's gonna, what I'm looking for is no rattle and for it to not fall out on its own. So in this case, in this receiver's case, the 7085 is actually gonna be the winner. So we're gonna use the 7085 there at the end. However, we don't have a bushing for the back end of here. And if you recall, the bolt itself, there's really not a lot of bearing surface. Now here is a bolt from a Remington 700. A little bit different geometry here. Obviously it's a lot longer. Well, a bolt in a typical center fire has two bearing points. Typically, the bolt body is going to be bearing inside of that receiver in these two areas when it's actually locked up. And it has two locking lugs, 2, 3, sometimes 9 locking lugs that actually, when this is inserted into the receiver and locked closed, these two bolt lugs essentially is what is preventing this entire mechanism. It is actually stopping it inside the receiver. So that's where it locks up. So in a centerfire rifle, that's where the key surfaces are. So in this particular case, in a centerfire rifle, we would true up the backs of those lugs so that they're bearing perfectly square inside the receiver. The inside of the receiver surface would be cut square, so those two surfaces would be touching perfectly. And we would, most of the time, we would sleeve the bolt body here so that the front and back bearing surfaces have as little play as possible inside of the receiver. Well, in this bolt action case, and a lot of 22 rimfire or rimfire bolt actions, that's not the case. We don't have locking lugs. So if you look at it and think about it, this bolt is bearing mostly here and here inside the receiver. This back end is the firing, kind of the firing pin configuration. The striker is back here. This is where it's cocked on the sear of the trigger. and you've got your forward tension of the spring here. So really the locking surface is right here on the handle. That's where the bolt is actually stopping and being prevented from shooting back upon detonation of the cartridge. There's no locking lugs, there's no locking surfaces anywhere in here, anywhere else. So there's a singular locking surface. And there's really nowhere to sleeve this style of bolt because this is obviously a separate component. And up here you've got way too much stuff going on. You can't put a sleeve around that, and it's not even a full cylinder. So this is a little bit of a trade-off and a disadvantage of the 22 bolt action, at least in this CZ, in this particular case with the CZ. So we've kind of got to work around a lot of these things. Which leads us to the fact, where do we want the bushing in this particular case? So basically, do we want the bushings closer together, as in here and here, or a little bit further apart, as in back here? The way I'm thinking about it, we've got our front bushing that's going to bear here, right about there. That's filling up this portion, which is good. And then we basically have a lot less support in this particular area here, and this is actually fully encapsulated in steel. So what we're looking for here is a bushing that's going to ride in this area here. I don't really feel it's best to be back here. It's not going to be supported as well. So here's a 710. That bushing will not go any further in. So we're going to want a bushing that actually fits this surface a little bit better. So these components are such a close fit, we're going to have to use a little bit of oil because we certainly don't want any binding in there. Okay, so with a little lubrication, we've got a lot nicer fit. These are nearly identically sized surfaces. So we don't want to damage anything, we don't want to force anything. 7095. Let's just use a little whey oil to make sure we're not forcing anything in here. Okay, now we have filled the inside of our receiver with exactly appropriately sized bushings. These are not tapered bushings, these are filling the exact bolt bore raceway. As you can tell, there is nothing rattling, there's nothing coming loose, and they're not falling out on their own. So now we have our bolt bore raceway filled, which gives us the ability to use our indicating mandrel. So this is the key component that it will enable us to dial in this receiver. So just like the bushings, this is exactly a 1/2 inch size, and the bushings here are exactly a 1/2 inch size. So what we're going to do is feed this rod in to the bushings. Now you can tell, again, this rod is not falling out on its own. And the very nice thing is these two bushings meet exactly together. I'm not forcing the rod in. So that means the action itself is very straight. There's no play in the bushings, and they're exactly fit to the internal diameter. And our perfectly straight indicating mandrel is sliding in and out very freely. Again, it's not falling out, so there's no play there, but I'm not forcing it in. So if this action was warped or skewed slightly, this alignment mandrel would not slide through this action as nicely as it does. In my experience with centerfire rifles, if you encounter this and you cannot feed the two together, you cannot feed this bar through, that tells you that the action's warped and you can't really help anything. Because even if you cut these features true, right when you pull this out, the action's still going to be misaligned. So that's a very good sign. This action is very straight. So I like to see that. Now what this is doing now is enabling us to get basically a dial test indicator on this mandrel. So we're going to be using our action truing jig here. This is basically an 8-jaw chuck. And just like in my other centerfire rifle videos, this action, we're going to get this in the happy place where we can get 4 bearing surfaces on the front and the back with these giant cap set screws here. That will allow us to dial this receiver inside the lathe perfectly true, both, like I said, like radially. So like you would center up bar stock, we're going to center up radially like this, and then axially. So once that's running perfectly straight, we can come in there with a carbide single point cutter and cut threads inside the receiver here for the barrel, and then we can go in there and face the receiver square. So once the barrel has the corresponding threads cut and a square shoulder, those two surfaces will butt up together perfectly square 90 degrees and have a perfect junction and a perfect union. So we'll get this installed in the lathe and start that process.